In a viral video, a human-shaped robot is seen breaking free from a miniature jail cell in a way that seems straight out of a Hollywood blockbuster. What if I told you that this was not just a special effect from a movie, but an actual revolution in robotics, especially in shape-shifting robots? In this video, you will get to know about a human-shaped robot that can transform into liquid metal and slip through bars. You will also discover how this breakthrough could change our approach to robotics and its impact on our future. If you've ever been fascinated by the character of T-1000 from Terminator 2, you would not want to miss this video. The robot's abilities and its practical implications will leave you astonished. Shape-shifting robots look as if they're straight out of a sci-fi movie. Well, it's the engineering behind them that has made this marvelous innovation. Did you know that traditional robots are pretty inflexible because of their hard bodies? It can only move and operate within a set range of motions, making them unsuitable for certain tasks. That's why scientists have been working on soft-bodied robots that can change their shape to move in all sorts of ways. Soft-body robots are still solid, which means they can't fit through openings smaller than their bodies. This limits their ability to access hard-to-reach places and perform certain tasks. Scientists have been experimenting with liquid-based robots that can fit almost anywhere. Even these liquid robots are weak and can't withstand much pressure, so an international team of engineers have developed a revolutionary new material that could give rise to a new class of robots, the Magno-Active Phase Transitional Matter, or MPTM. This is no ordinary robot. It's a shape-shifting machine that can transform into liquid metal and slip through bars. But wait, it gets even better. Once the robot is free, it coalesces back to its original shape, just like the villainous T-1000 from the Terminator movie. MPTM was inspired by the sea cucumber, which can rapidly and reversibly change its stiffness. Senior author and mechanical engineer Carmel Majadi of Carnegie Mellon University explained that the challenge for engineers was to mimic that in soft material systems. What exactly is this futuristic material made of, you ask? The researchers embedded magnetic particles into a base of gallium, which is the star ingredient of this invention. It is a unique element with an extremely low melting point of only 85.6 degrees Fahrenheit. This allows the material to easily transition between a solid and liquid state. With the application of magnetic fields, it acquires the ability to transform and move in ways that were only once thought impossible. How does it all work? By exposing the gallium to a magnetic field that keeps changing the direction it's pointing, the team can control when the metal melts. As a result, all the magnetic particles suspended in the gallium move around, creating heat and transforming the metal into a liquid form. Once the metal is melted, scientists can use magnets to manipulate its shape and move it to wherever it needs to be. Whether it's big or small, or in any other shape, this robot can do it all. When the robot needs to solidify once again, the team simply turns off the magnetic field and allows it to cool back down. The possibilities are endless with robots made of this fantastic material. In its solid form, the robot boasts a mechanical strength of 21.2 megapascals and a stiffness of 1.98 gigapascals. This enables it to carry objects an impressive 30 times its own weight. The embedded microparticles also allow for more flexible mobility with speeds of up to 1.5 meters per second. The real magic happens in liquid form, where the robot is free to elongate, split, and merge, thanks to the incredible ability of magnetic particles to rotate and reorient their magnetic poles. The lead author of the study, Professor Chengfeng Pan from the Chinese University of Hong Kong, explained that MPTM's ability to switch between liquid and solid states grants robots much more functionality. Unlike existing phase-shifting materials that require electrical currents, heat guns, and other external sources to transform, MPTM has an extremely fluid liquid phase compared to other shape-shifting materials. To test the robot, the team used magnetic fields to make it jump over moats and climb walls. MPTM can jump up to 20 times its body length. They were impressed when it split itself into two smaller robots to move objects around before joining back together. It was like watching a sci-fi movie come to life. To demonstrate the robot's versatility, the team showed how it could perform tasks in hard-to-reach places. They melted the metal into a threaded screw socket and allowed it to harden in place. The researchers were able to use the MPTM robot to solder a small LED into a hard-to-reach circuit by having it act as a universal screw. The robot melted down, filled a threaded hole, and then solidified to hold two plastic plates together. It was like having a magical robot that could adapt to any situation. The researchers didn't stop there. They wanted to see if this technology could be used for medical purposes. They tested the robot's ability to remove foreign objects from a human stomach and deliver drugs on demand. It was like having a tiny superhero robot inside your body, ready to help whenever needed. In another test, the robot was used to deliver drugs to a specific location in the fake stomach. There is a catch. The human body's internal temperature is much higher than the melting point of gallium, so using it in a medical procedure while a patient is awake is currently not feasible. However, fear not. The research team is already one step ahead and has its sights set on gallium alloy that can remain solid inside the human body when needed. This means that gallium's remarkable properties could potentially be harnessed for medical procedures in the future. While further testing is needed to determine the substance's biocompatibility in humans, researchers speculate that patients may one day enter an MRI-like machine that can guide ingested versions of the material for medical procedures. Imagine the possibilities for manufacturing and construction with this game-changing innovation. Say goodbye to the days of searching for the right screw to fit a certain hole. With this amazing material, you can create a universal screw that perfectly adapts to any shape or size. It is also incredibly strong, being able to support a weight of up to 10 kilograms. No more wasted time and resources trying to find the perfect fit. Picture this: a massive earthquake rocks a city and rescue workers are struggling to find survivors trapped under the rubble. This is where liquid robots come in. They can transform and squeeze through tight spaces to navigate the debris and locate survivors that are impossible to reach otherwise. They could also be equipped with cameras and sensors to provide crucial information to rescue teams. This will help save lives and reduce the risk of further injuries. Similar research has been carried out in the past. For the first time, they have identified a material that possesses the unique ability to change its shape while also being capable of bearing heavy loads. This solves a long-standing challenge faced by miniature robot makers, who previously struggled to incorporate both morphability and strength into their designs. With all these possibilities, there are a lot of challenges that need to be addressed before these robots can be put into practical use. They are currently difficult to control accurately, which makes it hard for them to be used in real-world applications. Researchers are finding ways to use this robot for medical and engineering problems. They are determined to continue exploring its capabilities. While it's understandable that comparisons are being made between the T-1000 character from Terminator and the creation of Pawn, there are limitations to how far these comparisons can be taken. According to researchers, the robot still requires an external heater for melting and an external magnetic field for controlling movement and shape change. In contrast, the T-1000 is fully autonomous. In a similar case back in April 2022, the Chinese University of Hong Kong scientists created a state-of-the-art slime robot that can be magnetically manipulated to retrieve inadvertently ingested objects in other real-world applications. Nonetheless, this liquid metal robot is like something out of a dream. Its shape-shifting abilities combined with its medical and engineering applications make it a remarkable innovation. The researchers are determined to continue exploring its capabilities and find ways to use it to solve real-world problems. The once fictional concept of liquid metal robots is now a reality, and the possibilities are endless. Who knows what amazing things this robot will accomplish in the years to come? It's definitely something to look out for. Stay tuned for more updates on this amazing technology. Click on the next video for more on the world's most advanced artificial intelligence.